Hi guys, we're going to go through some work here on finding the gradient and y-intercept of a straight line. You may have already seen this, but I just want to give you a quick run through over the course of the next period here. Okay, so every straight line is always given. It can always be read in the format of y is equal to mx plus c. That's what we see in this green box here. When a straight line is in this format, then what we can do is we can always read off the gradient and y-intercept. So the format is y is equal to mx plus c, where the m value is the gradient and the c value is the y-intercept, i.e. where it cuts through the y-axis. In example 1 here, we have got an equation of a straight line which is y is equal to 4x minus 2. Now, I can easily find what the gradient and y-intercept is of this because it is in this format of y is equal to mx plus c. So the m value is the number that multiplies the x. The c value is the number that stands on its own. So the m value is equal to 4, so that's the gradient of 4. And the c value is equal to minus 2. So therefore, it cuts the y-axis at 0, minus 2. The graph over here on the right-hand side shows this. Okay, so this is the line with equation y is equal to 4x minus 2. Because it cuts through the y-axis at 0, minus 2. And it indeed has a gradient of 4. If you remember that the basic way to find gradient is m is equal to up over along. Well, the up value is going to be 4. The along value is going to be 1. So the gradient is going to be 4 over 1, which is 4. Okay. Let's take a look at the next example here. So 3 quick examples, just pulling off the gradient and y-intercept. So in the first one, example 2a, we have y is equal to 3x minus 4. So here the gradient is going to be 3. And the y-intercept is going to be minus 4. In the next one, the y is equal to minus 10x plus 9. The gradient is equal to negative 10. And the y-intercept is 9. I.e. it cuts through the y-axis at 0, 9. The last one, y is equal to a half x plus 4. The gradient is equal to a half. And the y-intercept is equal to 4. So that's just basic ways to pull out the gradient and y-intercept. That is something you should already have covered. If not, then it's all here for you. What we're now going to do is we're going to go on and have a look at the equation of a straight line, actually making up the equation of a straight line. So when you have a gradient and a y-intercept, then if you use this format, you can actually give the gradient of a straight line, i.e. the thing that identifies what the direction the straight line goes in and how steep it is. So example 1, it says, find the equation of the line with a y-intercept of 3 and a gradient of minus 5. So it's the reverse process to what we were doing previously there. We have the gradient is equal to minus 5. And the c value, the y-intercept, is going to be 3. So put those two values into the equation here for m and c. So I get y is equal to minus 5x plus 3. And that's it. If you know the gradient and y-intercept, then you just put it into that format of y is equal to mx plus c. Part B, it says find the equation of the straight line through 0, minus 10 with a gradient of 2/3. Well, that's going to be pretty simple again. So we know that the gradient is equal to 2/3. And we know that the y-intercept is going through the y-axis at 0, minus 10. So the C value has to be minus 10. Again, put it into the format of y equals mx plus c. Replace m with 2/3. So y is equal to 2/3 x take away 10. Okay. Okay, let's take a look at example C. I want to find the equation of this line. So it's slightly different, but not too much. So our straight line is going through the y-axis here is 0, 3. So the C value is 3. But for this, we don't actually know what the gradient is. So when you don't know what the gradient is, you actually need to find the gradient. So remember, to find the gradient, we use the formula m is equal to y2 minus y1 over x2 minus x1. So our two coordinates are going to be 6, 4 and 0, 3. That's what we've got there on the graph. So label them x2, x1, y1, x2, y2. And then just feed them into our formula. So m is equal to 3 take away 4 over 0 take away 6. So that's going to give me 3 take away 4 is minus 1 over 0 take away 6 is minus 6. Therefore, the gradient has to be a sixth. So I know that the gradient is 1 over 6. I know that the y-intercept is 3. Put it into this format of y equals mx plus c. So I get y is equal to a sixth x plus 3. Okay. And final example here. To find the equation of a straight line, again, we need to know the gradient and where it cuts through the y-axis. So straight away, we can tell where it cuts through the y-axis because one of our coordinates is actually on the y-axis. We know it's on the y-axis because it says 0, 4. Any coordinate that starts with 0 is always going to be on the y-axis. So straight away, we can find the y-intercept. It's going to be 4. And this example is incredibly similar to the previous example because we just have a coordinate and where it cuts through the y-axis. This time, you're just not given it as a diagram. So what we need, we've got the y-intercept, now we need to find the gradient. So again, use your gradient formula, label your points first. So this will be x1, y1, x2, y2. So gradient is equal to y2 minus y1 over x2 minus x1. So that's going to be 8 take away 4 over 2 take away 0, which will give us 4 over 2, which is 2. So I have my gradient. My gradient is 2. I have my y-intercept. My y-intercept is 4. Bring it together. So I get y is equal to 2x plus 4. And that's it. So now what I want you to do is, from the straight line sheet that you have, can you do questions 1, 2, 3, 6 and 7? Some of this may be familiar to you already. If it is, just go ahead and do it. Get more practice on it. And if you have any questions, then feel free to play this video back. Okay? I'll upload this to the Teams page as well, so you can look at it at home as well. Okay?